So hello everybody, Neil here, the CEO and co-founder of Portainer. And today I'm going to take you through a little feature that we've added recently, which is GitOps with Portainer. This feature is still relatively new in its life cycle, and we are very, very receptive to feedback. Just a word of advice to begin with: we're not trying to build a product that competes with the big boys like Argo or Flux. They serve a very, very specific purpose for larger organizations with more complex workflows. Our GitOps solution is designed to get you started with GitOps. So to get you from a ClickOps type construct into a new GitOps world, our whole goal is to help you with that. So just straight off the bat, we're not trying to build a product that's better than Argo or Flux. We're trying to build a product that gets you started with GitOps disciplines. So just that up front. Okay, so what is Portainer? So I've used many different words and sentences to describe what we do, from a container as a service platform, to a self-service portal, to a container management tool set, to a container management platform. We are now using the service delivery platform for containerized applications. So Portainer is there to help you get started with your adoption of containerization. It's there to help your current team with their current skills embrace the value of Kubernetes and Docker without having to retrain themselves or spend vast amounts of time learning and iterating and practicing before they get maximum benefit from these technologies. So we're this piece of technology that sits across your infrastructure and radically simplifies the use and management of containerization. That's our goal: centralized service delivery platform. We sit atop of any type of backend platform. So be that Docker on your desktop, Docker in servers in a data center, Kubernetes that you self-host, Kubernetes at the edge, Kubernetes in a managed Kubernetes provider. Doesn't matter. We will support all of those platforms through Portainer. And from Portainer, we let you choose how you want to engage with the platforms. For those that prefer, you can use our intuitive web-based UI. And that has both an admin side, where an administrator can configure policies, configure role-based access control, configure all of the elements around platform governance. There is an end user side where developers or DevOps people can log into Portainer and, using our wizards and forms, deploy and manage applications. Or if you prefer not to, you can actually use third-party tools through Portainer, because we are in fact a centralized Kubernetes API. So you can use tools from things like VS Code or Lens, connect them to Portainer's public FQDN, and we will route you securely using your assigned access control and RBAC to the backend cluster. You can also use your CI/CD tools if you so desire. So Portainer sits in the middle between your users and the machine, and securely controls access, governs policies, without having to worry about managing the underlying clusters separately. So we're this unifying layer that helps you get going. Now, classic CI/CD pipelines. Now, this is not GitOps, this is classic CI/CD. It's a very sequential process, and it really is a deploy and pray type model. So your devs commit code, the code is built through some CI system. So it takes whatever inputs it needs, it builds an image, it pushes an image to a repo, it tests the image through a container, it goes through some approval and release process. It's then deployed against a cluster, and then it lets go. And it's then left up to the cluster operator and the developers and operations to manage it in production. The only time it changes is when there is a change and the CI/CD re-triggers, and it will rebuild, re-release, redeploy, and override the current system. But that's a very traditional CI/CD pipeline, very sequential, very deploy and let go. But the problem with that is you never actually know that what's in production now actually matches what was supposed to have been built from the CD deployment system. So the CD simply asks the cluster, go build this. The cluster says, okay, and then the CD system lets go. Sometime later, an administrator might make a change. The running configuration might deviate from what was expected, and that deviation can remain unchecked and will never change until the CI/CD system reruns and overrides what's there, which could be weeks, months, even years for some far slower type of organizations. You also find a lot of time that devs don't want to rely on someone to build the CI/CD system for them, or they just want to do something right now. So often you'll find devs just saying, just give me access, and I'll just do it manually. I've got kubectl, I've got Docker Compose, just let me edit, I'll do it, or Helm. The other thing is if you have a full cluster failure, how easy is it to actually recreate the whole thing? You'd have to go and rerun all of your CI/CD pipelines to redeploy it. It's not that straightforward. And how do you roll back? If you make a change, how do you roll back to a prior version? The CI/CD system doesn't really have a really nice integrated way to actually get back to a prior. So you often have to delete everything and then redeploy. So delete the running system, redeploy something. So CI/CD was good, but now GitOps is better. So GitOps's whole ethos is to ensure that what was asked for through the actual deployment process is what's running and is what always remains running. That what's running in the cluster is never allowed to deviate from the definition that's held in Git. So if an admin or a user wants to make a change, they don't make a change in the cluster, they make a change in Git, and the change is then propagated through to the cluster. So you always have a single source of truth, being the Git repo. The Git repo is versioned. It has a very simple Git history, so you can roll back to prior versions very, very quickly. And if someone makes changes in the cluster, override those changes at the next loop cycle to revert any changes made. So always have a single source of truth, always keep consistent with what's requested in Git. So GitOps overview, and I'm sure if you're in this session, you probably heard of GitOps by now. It's pretty much flavor of the month, but it's all about declaring how the application is to run. So you say, I want my application to look like this. It's to be deployed this way. It's to have X replicas. It's left, the actual deployment is left up to the underlying platform. It's simply an administrator declares how the application must run, and then that is held, that manifest is held in Git and then referenced by the underlying cluster. Again, single source of truth. There's no chance of deviations. There's no config drift. But also you've got the centralized management and control. Users don't necessarily need to have any access to Kubernetes whatsoever. So it's a very nice safety buffer between users who may not necessarily know how to drive Kubernetes correctly and Kubernetes itself. So users will simply commit code. The CI and the GitOps engine will take care of the rest. Now that's not always the case, and I've been following quite a few Reddit threads that said what is the best way to give your users access to your cluster, and interestingly enough, there was a great number of responses that said don't, it'll cause outages. But equally, there was another whole group of people saying absolutely users should have access. How are they supposed to learn and get better and improve their applications reliability if they don't know how things are running in the cluster? So it was pretty split actually. But anyway, it gives a buffer between users and Kubernetes. The rollback is very, very simple. You can just go into Git history and say roll back to a previous version, and the GitOps engine in the cluster will instantly pick up that change and basically roll back as well. So it's very, very simple if you make a mistake to roll back. Again, Git-based version control. It's actually very easy for you to do a Git diff. So if you have a version that was running previously and a version that you want to run now, you can actually diff them and you can see the changes that are made. And it's very, very quick and easy to recover. You can just basically repoint your GitOps at your repos and they'll all redeploy in seconds up and running again. So very, very quick and easy to get up and running. So GitOps, just standard GitOps pipelines, right? So you've got the build pipeline and you've got your GitOps workflow. There's no classic CD here. So the build pipeline simply takes the code, it takes a Docker file, and it creates the build manifests, so the image files from the Docker file, and pushes them to a registry. So there's the build pipeline, and that is still a traditional CI system. And with GitOps, you still need a CI system to do that for you. Now that could be GitHub Actions, it can be any one of a number of CI tools, but you still need a CI system to go and build the images for you. As part of that pipeline, you also are updating a manifest. So there's either a pull request or automation that updates the deployment manifest that's held in Git that says iterate or increment the image release number or version number or tag from version 0.1 to version 0.2. That is then held in Git. You can go through an approval process. So using Git, you can actually review the PR and then merge the PR. Once it's reviewed and merged, then the GitOps engine will basically pull that change or poll for that change and then deploy the change in the environment, prod or non-prod. So it's a very, very simple process with PR review points as traditional Git code review processes. Someone submits the PR, someone reviews the PR, merges PR, it's then pushed through and pushed into production. So again, Portainer's job is to make GitOps really easy. I don't know if you've started using any other GitOps tools, but there is actually quite a barrier to entry with those tools. It does require someone with knowledge of those tools, or at least want to obtain knowledge of those tools, to deploy them, to learn them, to maintain them. And it's really not that simple for smaller organizations to get going with GitOps. So we believe GitOps should be easy, really easy. We want to have a GitOps automation engine with just the right amount of functionality. We're not trying to be this big behemoth of a GitOps engine. We want just enough. What are the 8 or 10 most critical features or most commonly used features from Argo and from Flux? Let's put those into Portainer to get people started on their journey from ClickOps to GitOps, or from manual to automated. Just the right amount, because the more functionality you add, the more complexity you introduce. And Portainer is always trying to walk this tightrope between functionality and complexity. We want to be a tool that is incredibly easy to use and super intuitive. We have to be very, very careful that we don't go AWOL and start adding really, really, really rich, comprehensive functionality, because with that comes complexity. We wanted to have it so that developers can actually configure their own pipelines without the need of a dedicated DevOps. Developers should be able to say, I want to deploy an application. Here's my manifest. It's in my own personal Git repo. Go deploy it. They should not need a DevOps professional to help them with that process. It should be so easy that a dev can do that. Again, as per the first point, we want to cover 80% of the use cases where you need a GitOps solution that just works. There's 20% of use cases, maybe there's 30% where you absolutely need the depth of features that something like Argo or Flux has. But for the vast majority of the time, you don't. And it may well be that you choose to run both solutions. You use Portainer for your more streamlined everyday workflows, and you have something, a bigger tool that takes care of the more complex ones. So our GitOps functionality is not just Kubernetes. It also works for Docker and Docker Swarm. And in the future, spoiler alert, Nomad as well. So if you have devs running Docker on their machine, and you have Portainer running centrally and an agent running on their machine, those devs can use GitOps functionality for their machine too. It's not just for centralized production clusters. If you run Docker Swarm, then we work fine on that too, and of course Kubernetes as well. So it's really, really useful if you have a really hybrid environment, and you want to enable GitOps right the way from your dev right the way through to production. So really, really comprehensive capability across there. Now, our GitOps solution actually runs inside Portainer. It doesn't run in the cluster. You don't install or configure anything in your clusters anywhere. everything runs inside Portainer. There's no load on your clusters. There's nothing to install. There's nothing to maintain. There's no version mismatches to worry about. It's all in Portainer. Every single time that we release a new version of Portainer, the version of Portainer will include support for the latest version of Kubernetes, the latest versions of Docker, whatever it is. So as long as you're running Portainer, you don't have to worry about version mismatches for your CI/CD pipelines or GitOps pipelines. And as I've said a couple of times here, Argo and Flux are awesome GitOps tools. Don't get me wrong, they're amazing. And in the future, you'll probably see us integrate further with Flux. But when you're ready for their depth of capability and overhead, that's when's the right time to do it. That is not necessarily day one. And again, Portainer gets you started right now with near zero operational overhead. It's so simple to configure, so simple. So Portainer's version of GitOps is actually very similar to the one previously. Nothing changes. We're a full GitOps engine. The only difference is the deploy phase. We can deploy to Kubernetes, Docker Swarm, or Docker Standalone, as I said before. Everything else is exactly the same. It's just GitOps. It's GitOps principles, it's GitOps architecture, same thing. But you hit the one instance of Portainer and we can run anywhere. The other interesting thing is because GitOps leverages the Portainer agent functionality, we also allow you to do GitOps through our Edge agent to remote environments that are sporadically connected networks. So if you have a cluster out there in a factory or at a telco edge point or in a store or warehouse or retail, anything like that, and it has sporadic network connectivity or satellite connectivity or whatever else, and you're using our Edge agent, our GitOps engine works with that too. So we will basically initiate a remote call home. So the next time that the device has internet access or network access, it'll call home, it'll see that there are outstanding tasks for it, and it'll execute those tasks for it. So it's not just for permanently connected WAN services, that's also fine for Edge. So how does it look? It will look very, very familiar, because what we've done is taken our manifest deployment page and we've simply changed or added a switch, which is just automatic updates you'll see in the bottom. Now with automatic updates turned off, it's just a one-time git deploy. With automatic updates turned on, we now start a GitOps reconciliation loop. So when you turn automatic updates on, we will now poll Git, look for the actual merge IDs, and whenever we see these things change, we will now go and redeploy the application if there are any changes tagged. So it will look very, very, very familiar for those of you used to using Portainer and used to using our Git integration. It's that extended now with GitOps. So we let you choose the namespace that you want to deploy into. We let you deploy from Git, obviously. We let you deploy from a Git URL. Now it's Git, it's not GitHub. So it's any Git, GitLab, Git. There's any number of Git servers out there you can use. It's just Git. The repo reference, so either a branch or a tag name you can point to. The path to the manifest. So we support one or more manifests. So if you have a manifest for your deployment, a manifest for your server, for your service, a manifest for your ingress, you can connect to all three of those manifests. We will pull them and deploy them, and we'll monitor those for changes. So multiple manifests or single. We support authentication. So if you have a private Git repo, you need to authenticate to get access to it. So you can add your Git authentication. Currently, it's personal access token, not SSH keys, and I'll cover on that more on that later. So automatic updates. So we by default do a loop every 5 minutes. So every 5 minutes, we'll go check for changes. Now you can make that shorter or longer, but by default, it's 5 minutes. There's also a button for those of you like me that are impatient. You can push to say check now, and it'll just go check now. So it'll poll. We also wanted to add the ability to have a push. So we actually can configure a webhook trigger, and then you simply just need to curl the UUID, which will initiate a poll. So you could have your CI tool actually tell Portainer there's been a change. Portainer will then go and poll for the delta. It won't poll without webhook. So you can choose how you want to do this, either a never-ending poll cycle, a poll loop cycle, or only poll when there's a trigger. And force redeployment, which I'll show you again, this is a feature that will block local changes. So automatic updates will poll Git. If there is a change, it will deploy the change in production. If there is not a change, it does nothing. It sleeps until the next cycle. With force redeployment, it says, I'm going to send the instructions to Kubernetes or Docker to make sure that what's running matches the manifest that's in Git, even if it hasn't changed. So that will actually override any changes that are local, regardless, even if there's no change in Git. Now that's off by default, but you can turn it on, in which case that blocks any local changes. So what makes our GitOps different? We run in Portainer, not in each cluster. Our pipelines run in the user context. So because Portainer is running the GitOps engine, there's no service account that the GitOps service is running in. So Portainer is simply running the engine. So whoever defines the pipeline, so the GitOps pipeline, whoever defines that, it's their context that the application runs in. So from an audit perspective, from a security perspective, it's that user or a service account that the application runs in. It does not run as some quasi-cluster admin role. It runs as the user. So you can actually really, tighten down the security. So the user account only has access to one namespace, and then log into Portainer as that user, create the GitOps application deployment, and from that point on, that application runs as that user context in a Kubernetes perspective. So really minimizes the actual risk of security. It really minimizes the chance of breakout, and easy audit because it integrates with Portainer's activity logs. And devs can create their own pipelines. They don't need to know much about the GitOps engine. They don't need to go and learn any of these big tools. They can just click, and their pipeline is built. Very, very simple and easy to use. So what works well? As I said, this is our first version of this GitOps engine. It's going to get a lot better. What works well at the moment? Deploying an application from a single Git repo. So based on one or more manifests. A reconciliation loop that's based on a 5-minute poll or the webhook trigger. The environment force redeploy, so to make sure that no one makes any changes. Multi-service manifest, so if you want to have multiple manifests, you can do so. And Git authentication using tokens. So that's what works really, really well. What doesn't work well, or what's in our roadmap? Helm chart support and customize. So there's no customize right now. It's just Kubernetes manifests. No Helm chart support either. Just manifests or Kompose files for Docker. Git authentication using SSH keys rather than access tokens. Deploying an application that comes from multiple repos. Interestingly enough, this is a use case that I did not think was common, but we've had quite a bit of feedback around this. This is a need. Is you have a Git repo for your backend service, a Git repo for your front-end service, maybe other Git repos for other elements of your 12-factor application. So multiple repos, but all of these together are the application. So being able to deploy an application bundle from multiple Git repos. Interestingly enough, from looking at the other GitOps tools, they don't do that either. So I'm not entirely sure where this thing came from. The YAML defects. So right now, if there are issues with the YAML construct, we just silently ignore it. We don't error, we just silently ignore it. And what we want to do is actually try and parse the YAML file and find a way to alert the operator rather than the change being ignored. So if a dev or a DevOps person pushed a change to a manifest that is in Git, the next poll cycle, Portainer sees that the YAML is malformed, we will simply ignore it, and the running configuration that was running will keep running. So we want to try and have an alert that says, we tried to do something, but we couldn't because of a defect. Go and make a change or do something to that YAML file. So we want to try and find a way to actually parse the file, make sure it is a properly syntaxed YAML file, and if it's not, then generate an alert as opposed to simply ignoring and trying to catch up next time. We also want to specify a Git repo rather than manifests one by one. You may have a repo that has 20 or 30 manifests in it. It would be very nice to say, I want to deploy an application based on all manifests from this repo, go, as opposed to manifest 1, manifest 2, manifest 3, manifest 4. So that's something else we want to work on. And these things we are looking to work on within the next 6 months. We have a real focus on GitOps, so we really, really want to work on these. My current goal is to have all of these concluded in time for KubeCon North America. So that's kind of my internal working goal. Mileage may vary depending on priorities from customers, but that's kind of what we're thinking at right now. So I'm going to give you 5 demonstrations. I'm going to start with Docker because we still have a lot of Docker users and a lot of people out there still love Docker. So I'm going to show you Docker first, and I'm going to use our GitOps engine to deploy to a Docker host using a really simple Kompose file. I'm then going to deploy an application to a Docker host where we have environment variables in the Kompose file. I'm then going to deploy the Kompose file to a Kubernetes cluster using Kompose with a K. I'm then going to switch to pure play Kubernetes, and I'll deploy an application to Kubernetes, use a single manifest and one with multiple manifests. I'll also then show you in demonstration 4 how to break it. Like if you break the application on purpose, make a change, how we can actually forcefully undo that change through our forced redeploy. So these are the 4 demonstrations I'm going to take you through right now. So I have here a Git repo. It's private, only because I want to show you authentication, not because I have any secrets. In here, I have 3 folders: Docker, Kube, and Nomad. As I said to you, watch the space for Nomad support. Inside the Docker folder, we have a simple Nginx Kompose file that will deploy an Nginx service. We have a simple application that has in here some variables that we will populate. In the Kubernetes environment, we have a single large manifest that contains both a deployment and a service. We have a deployment that is just a deployment, so just deploying an instance of Nginx here, single replica, and then the corresponding service that will then execute and publish the deployment as a service. And we have a simple Kompose file as well. So it's a Kompose file that's been tickled with some Kompose with a K labels to actually work against Kubernetes. So very, very, very simple things here. And again, obviously your environment would look far more complicated than this, but now just looking at a question, the auto update is simply looking at this ID. If this ID changes, then we see there is a difference, and then we poll the repo and look for new versions of this file. Okay, so in Portainer here, I will start with Docker. So here I have an environment that's running out on a cloud. Doesn't have to be in a cloud, can be anywhere, it doesn't actually matter. And I have a Docker environment. It happens to be Docker Swarm, but doesn't matter, it's a single node. And I have a Kubernetes environment from a managed Kubernetes provider. So if I come into the Docker environment, I have nothing running but the Portainer agent. If I come into stacks here, I say I want to add a stack, choose Git repo. And then all we need to do is paste in or type in the repo. Just because I'm lazy, I've got that pre-prepared. We need to put in the path, and I'm just going to use the main. And in my case here, it is Docker, and it's the nginx.yaml file. I want to authenticate, and I want to authenticate with my credentials, and I want to do automatic updates. Here, I'm just going to have it at a 5-minute fetch interval. And oops, I need to give it a name. And now I can deploy. And this will now go authenticate to Git, pull down the manifest that's needed and deploy it. And if I come into services, you'll see there is a service that we've deployed. It's in fact already running now. And here it is here. Now I can come into here now, go into Docker. I can come into the Nginx file. I can edit this. I can change replicas from 1 to 2. I can commit the change. Now, again, you wouldn't normally commit to main. That's bad practice. I'm a naughty developer. So I now have 2 replicas, and within 5 minutes, you'll see this change from 1 to 2. Now, we're not going to wait 5 minutes because you'll all go to sleep. So I'll do a second one and we'll come back to that one. So now the next one I'll go back into stacks. I'll add a stack, git repo again. It's the same ref's head. This time it is, oops, docker droppy.yaml. And if you remember in here, droppy was expecting a tag called version and a tag called port. So if I try and deploy this at the moment, it would fail because I don't have anything in there. So I need to put in my credentials again, automatic updates, and now I can say add environment variables, version, latest, port 8989. And we will now go and deploy that. And that will now go and mesh the 2 together. And you'll see in here services. Here is my droppy service. It's using latest and it's using port 8989. So I was able to merge the generic Kompose file that was held in Git with an override environment variable in Portainer at deploy time. And again, that is now up and running. And again, I can make changes to the back end, and that would propagate through to here. Now I can also come into here and say, oops, say demo 2. I want to edit it. So let's say I want to change it from 8989 to 8990. I can do that, save settings, and that will then update also on the next reconciliation loop. So if we come back, this should eventually be at 2, and this should be 8990 because it's got this reconciliation loop that's going through. The pull always. Right, so the question around image pull here. So we added this feature in here, which is automatic updates, pull latest. Here we will force a pull from the registry that is referenced in the manifest, even if it is already running. So we will do a pull. It will check against the registry and pull down, even if there is one held in the cache. So if you think that, like, if you are reusing tags, now you shouldn't reuse tags, but if you are reusing tags, you can turn on pull latest, and we will always pull before we actually redeploy. So we'll do a pull, then we'll do the redeploy. So you can use this to try and work around any issues where you've got image cache issues, or if you're reusing image tags. So you can use this to work around that behavior. So while I'm waiting that in the background again, I will come in, and let me just refresh that. I will come in. 5 minutes is a long time when you're waiting for things to happen. I could actually get impatient, as I said, and come in and hit the button, pull and redeploy, which basically does it now. That just triggers the update right now, but I won't. So then if we come to Kubernetes as an example, I'll just show you the Kompose file and then we'll pause for a second. So I come into a Kubernetes cluster. I have created a namespace called GitOps demo. There's no quota, it's just a vanilla namespace. Now I can do the same thing. I can say applications, create from manifest. I'll put it in my namespace. This one's going to be demo 3. Git URL, put in the same thing. Refs heads. This time it's kube/kompose.yaml. Now I need to make sure, because I always do this. In this case, because it's Kompose and not a manifest, you have to click the Kompose format. And now we know to use the Kompose library inside Portainer. Again, authentication, authenticate, automatic updates, because that's what we want to do. And we can go deploy. That is then going to read the Kompose with a C file, create me 2 different deployments. And again, if I come back into here and go into kube Kompose, I had, again, you wouldn't do things like this. This is just simplistic purposes for now. Again, I'm a bad developer. I have a simple Docker Kompose file that is basically having a MySQL server and a WordPress server. You cannot just use a raw Kompose file and expect it to work perfectly in Kubernetes. You have to have these Kompose labels. Now, there is a whole bunch of Kompose labels you can add to enrich a Kompose with a C file so that it works properly on Kubernetes. So as you can see here, this here would simply be exposing port 80 and port 3306 on the cluster as cluster IP or node port. So what we want to do here is actually say, no, I want it exposed externally as a load balancer. So I had to enrich the Kompose file with these Kompose labels to support this. So with that done here, you'll see here, once I refresh, this is going to deploy both the database and the WordPress instance. They're both published. So if I come into WordPress, this is DigitalOcean, so this will take a little while to get the load balancer provisioned, but you'll see here it is configured, it's up and running, WordPress is running. I'm waiting for the load balancer, but once that comes up, we can click it. But this is basically deploying, and you see the waiting's here, it's still waiting for the load balancer. So we have to wait. But this is basically gone and deployed the application, the Kompose file with a C against Kubernetes, and is pushing this up perfectly fine. Now there's a whole bunch of limitations. Half of the Kompose spec, Kompose with a C, is not available in Kompose with a K. So it's kind of useful, but would I use it in production? Maybe not so much. For a developer, it's probably okay. But for me, if I was running a proper Kubernetes environment, there are actually Docker Desktop especially has a Kompose to manifest conversion tool. You can actually run it through a conversion tool. That's probably how I would approach it. But yeah, so secrets management with Kompose with a K, not its best work. So in that case, you'd have to pre-create the secret and then reference that. Much like volumes, if you want to use persistence, so if you were using a Kompose file and you were used to having the volumes command, yes, recording will be available. If you're using the Kompose command with volumes defined, those will not work against Kubernetes. You have to have pre-created the volumes, because all it's doing from a Kompose is a claim. It's not actually creating the volume. So there's a lot of workarounds in there. So you need to have a read up on Kompose with the K limitations if you're seriously going to use that. Now, hopefully 5 minutes is up by now. You never know. It is. So there we go. So now we have 2 of 2. This one is not yet updated because that was obviously a different loop cycle. So now we've already got the Nginx one. So we've got 2 of 2. So that's going to work there. So as you can see, and I can also come in here and scale it to 0 if I want, and it will shut down as well. So now let me show you the more rich Kompose, rich Kubernetes one, so I should say. So I come into applications again, create from manifest. Again, GitOps demo. This is demo 4. Same URL. This time, oops, refs heads again. This time it's kube/nginx.yaml, and this is a singular manifest that contains both the deployment and a service. So again, I want to authenticate with my credentials. I want to do automatic updates. This time I'm going to do force redeployment, and I'll show you why in a minute. So force redeployment, drop that to 3 minutes, and I'm going to deploy it. So that will now go and deploy me my single manifest demo. It's just a simple Nginx environment. It is published, so you can see it actually took both the deployment and the service. And you can see here is the service that we defined and the node port that it's listening on. So it took both of those. It is now currently running as well. So here it is up and running. Now, if again, I took a kube shell, kubectl get services -n GitOps demo. There it is there. So kubectl delete service single manifest demo service -n GitOps demo. Oh, it's because I can't type. So it's deleted. So again, if I get services, it's gone. If I refresh here now, it's gone. So as a naughty developer, I broke it. Now we'll just wait for the reconciliation loop and you'll see it come back. But in the meantime, I'll show you the next one. So again, create from manifest, same thing, GitOps demo. This is demo 5. Same thing. But this time here, we have a kube/deployment.yaml, and we have a /kube/service.yaml. And again, come back in here. You have the deployment YAML and service YAML. So we can do the same thing. So we've got, and you can have as many of these paths as you need. Again, authentication, automatic updates, and deploy. And again, that's going to take the multi-manifest here. So Portainer demo, again, here it is here now. So this is taken both of the service. Now this is a different port and the application is running. And if I edit this application, you can see it's coming from both kube deployment and kube service and from this repo. So you can see I'm using both of them there, and both of those services combined equate to the running configuration or the single manifest. And again, I can come into service and I could change the port. I can scale up. Like I can now go into deployment here, edit this, have 2 replicas, commit change. And again, based on the reconciliation loop, it will update. I can come in here now. Is this the one I did? I think so. I can come into this one over here and actually update it, pull and redeploy it, and that will actually trigger. It is pulling up that application. That will actually force a poll right now. So I want to wait 5 minutes, and that will basically now scale up to 2. So there you see it's already done it, scaled to 2. So I can either wait for the loop, and as you can see here, sorry, the single manifest demo has already repaired itself. It's repaired itself now, and it's back to published again. And if I went back to the kubectl shell, you'd be able to see that that service is now back. So it came in here. So again, it allows someone to break it for the reconciliation loop sleep period, but as soon as that sleep period is passed, it will remediate or repair whatever was done. So that's how simple it is to get Portainer's GitOps engine working. Now, again, is this the be-all end-all? No, this is the first version of our GitOps solution, and we will be working on this thing very hard. So we're going to take any feedback that you may have, any feature requests that you think we need to bring. Again, we're not trying to be another Argo or a Flux. We're trying to be a radically simple GitOps to get you going with GitOps disciplines, so that you're basically now managing Kubernetes from Git as opposed to deploying things manually from forms. In the future, we're actually working on something right now in regards to adding an application from form here. What we're actually working on is when you are actually filling in this metrics here, all you're actually doing is creating a manifest in the back end. Now, we don't ever show you that manifest. We simply create it inside Portainer, and then we deploy that manifest in the cluster. What we're working on is actually a button that's not only deploy application, but deploy with GitOps. So you can fill in the form, hit deploy with GitOps. That will then push it to a repo and then create an automatic deployment linked to that repo. So a very simple front end to let you go and create the actual manifest files. Just looking at the question here. So regarding Docker Compose, it seems we can specify container environments via a file. However, it doesn't look like we can specify such as an image tag. So let me be honest here. In here, in Git repo, with environment variables, you are supposed to, if the repo, and as you can see here, I even have this. So inside Docker, I had a droppy YAML file and I had a droppy env file, right? So this is literally the environment file that corresponds to droppy. Now, you are supposed to, and this used to work. This is, Portainer is not always awesome. This used to work. Now, if you were deploying an application from Git and there was an environment file in the same repo, we would merge the two together. So you did not use to use these tags. We'd merge the two together and auto populate any of the variables in the Kompose file from the file that we saw in the repo. Now, in the first version of this GitOps solution, we actually broke that because we're trying to be more efficient in our handling of the Git repo. And rather than cloning the entire repo to the Portainer server, we now only clone the files that are referenced to save space on your file system. We will be putting that back in the next version. So in the next version, you will definitely be able to have an env file in the repo that corresponds to the YAML. And as long as you have a stack.env or the same file name.env, we will automatically merge the two together. So we thought we were doing the right thing by not cloning the entire repo. It had unintended consequences, and we are rectifying that. So the next version will have that back again. So Nicholas, to answer your question, it will be supported. And yes, we do make mistakes every so often, but when we realize those mistakes, we remedy them as soon as practically possible. Now, in regards to the other options here, so again, as I said, the pull latest image and force redeploy. So pull latest image will always pre-pull the image. Force redeployment will always revise the running configuration with the manifest that's held in Git. Just to be safe and sure, we will actually go and get the version that's from Git anyway. So even if there's no change, we'll go to Git, get the latest version, and then redeploy it. We don't actually rely on a cached copy. We actually pull it, redeploy it, even if there's no change in Git. So this is a very, very safe way of ensuring your application is running. So that is the GitOps engine by Portainer, Docker, Docker Swarm, Kubernetes, and very, very soon Nomad, and very soon, by that I mean next week, Nomad support as well. So you'll be able to use this GitOps engine across all of those platforms moving forward. And again, actually, if I just quickly show you as a Nomad example here, it's simply a Nomad HCL file rather than a YAML, and you can deploy the same kind of thing through the GitOps engine as well. So very, very simple. Happy to answer any questions that you may have. The best way of reporting issues is through our GitHub issues tracker. We monitor that on a weekly basis. So you can open issues there. For users of Portainer Business, you have a direct line of access through to our support and success team. So you use that, but you're also able to open issues through the Git repo if you so desire. So we were monitoring that. I say we are very attuned to our GitOps engine. So any kind of features you think would make this thing better, stronger, faster, then we're all ears. Is this on CE and EE? It is on CE, absolutely. There are a few quality of life differences. For example, the pull latest image and force redeploy is a business edition feature only. Everything else is in CE. So very, very rich CE functionality. A secrets menu on my screen, but you do not have that on CE. Absolutely, you do. So depends on your environment. This is Docker. So if you are using Docker standalone, I'm using Docker Swarm. If you're using Docker standalone, there is no such thing as configs and secrets in Docker. Configs and secrets is a Swarm thing and a Kubernetes thing. So if you're using Docker standalone, you will not see configs and secrets in your menu. It's again configs and secrets here for Docker. If I switch to Kubernetes, you'll see config maps and secrets. Docker standalone, no such thing. In fact, I may even have one. No, I don't. Any other questions? We've got 8 minutes to go. Any other questions? I'm all ears. No. Very good. Hopefully that means we've made something monumentally easy and you're all madly in love with it. Just in case you weren't aware, Portainer is also a full Kubernetes API proxy. So you can actually get your kubeconfig file from here, and using any kind of local Kubernetes, kubectl or any locally installed client, you can actually proxy through to Kubernetes from your local machine through Portainer, as I said at the start. So that is the end of the demonstration. This recording will be available and emailed out to everybody. I encourage you to have a play with Portainer and our GitOps features, and thank you for supporting Portainer.